This one is number 37. I figured that one was kind of weird, so I'd go ahead and do number 37 on page 391. This is one, well, like all of them, you definitely need to put that in your graphing calculator so you know which is which. But you had one equation that was y equals e to the x, which kind of goes like that. And then you had one that was y to the negative ex, and so that's kind of like the mirror image, goes something like that. Okay, and then it said x equals 1, so that was a third line. So now you have three curves, and you want the region bounded by those three curves. Let me pick a different color here. So x equals 1 is the line where all the coordinates, x coordinates are 1. So what you want is this little region right in here. Okay, and you want the area of that region. So, oh, you know what? My graph is a little off. These look like they intersected right there at, it goes right through the origin, so that's where they intersect. So you are kind of already have your boundaries there. So they meet right there where x equals 0, and then they gave you the line x equals 1. So those are your boundaries, 0 and 1. So you've got integral of the first equation, my little green line there, that was the y equals e to the x. So it's e to the x minus e to the negative x. And your boundaries, you're going from 0 to 1. So, antiderivative. Remember, e is funky. E is its own derivative. If you ended up with e to the x, that means you started with e to the x. And the derivative of the exponent is 1, so you don't really need to show divided by 1. So then you have minus, again, it's e to the negative x. This time, though, the derivative of that exponent is negative 1. So you always divide by the derivative of the exponent, which is negative 1. So you get e to the x plus e to the negative x, and you're going to plug in your values of 0 and 1. So when you plug in 1 for x, you get just e to the first power plus e to the negative 1, which is 1 over e. Okay, so that's what we have there. Minus, when you plug in 0, e to the 0 power, anything to the 0 power is equal to 1. So e to the 0 power is 1. E to the negative 0 power, there's no such thing as negative 0, so it's just e to the 0. Again, that's 1. So you end up with e plus 1 over e minus 2. That's your value. One of the challenges for these problems, though, is that when you check the answers in the back of the book, you might go, well, that's not what I got. So the answer in the back of the book for here has this. It has e minus 1 squared over e. So it looks like a completely different answer than what I have here. Now they go ahead and give you, because it's e, they're giving you, and they're talking about area, they give you a decimal answer. Again, e is kind of funky. But if you were to multiply the book answer out, you know, you FOIL that out, you do e minus 1 times e minus 1, you would get e squared minus 2e, because you get negative 1e and another negative 1e, plus 1, and all that is divided by e. Well, if you distribute that e to everything, you're going to end up exactly what I got over there. Okay, like e squared divided by e gives you e to the first. Negative 2e divided by e, that's where that negative 2 came from. And then 1 divided by e is right there. Okay, so sometimes what you have to do if you're checking your answers in the back of the book is look at what they have, see if maybe if you multiplied it out, if you would get the same answer that you got doing the work. It doesn't mean yours is wrong, it's just in a different format, that's all.